Okay, this lesson is about the triangle sum properties. What did you guys learn yesterday when you were adding up angles in your triangles? When you add up the three angles of a triangle, it always equals 180 degrees. Somebody tell me what the definition of a triangle is.
It's a polygon with three sides.
Very good. Polygon with three sides. Let's look at the key concept.
My shoulder hurts. I don't know what I did.
Mine too, Emma.
You beat up your classmates. All right. If you did not write this key concept in your journals, I highly recommend you do it. If you really don't want to write it, go make a photocopy, cut it out, and paste it in here, because these are definitions that are really important for triangles for this lesson. A scalene triangle has no congruent sides, meaning each side has a different length. Each angle is going to be a different angle. Isosceles triangle means you have two sides that are congruent, meaning just slide it under the door. You can see them marked by the two red lines. And the equilateral triangle means that all three sides equal each other. And then classifying by angles, you have three acute angles, meaning they're all less than what? 90. Acute little angle, haha. The right angle means one of the angles is 90 degrees. Obtuse means you have one angle that is over 90 degrees. You're not going to be able to have more than one angle because then your vertices wouldn't connect. And then equal angular is all three angles are the same. Just very important, I don't know, definitions of triangles there. So let's look at example 1. I think this lesson was a fun lesson if I remember. Not real hard. I know, I'm a nerd. I called it fun. All right, so you see triangles in everyday life. Here you see it in the support beams. We're going to classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. So looking at this triangle, you see that they've given you some markings. Is there any markings that we need to pay particular attention to?
The little lines.
Yes, the little lines right here. I'm going to make them a little brighter. What does that tell us about this triangle? That those two lines are congruent, which if I were to ask you to classify it, what is this classified? Isosceles triangle. So then you would need to measure it. And how do we measure a triangle? Which they're in here. So come and get one, because you're probably going to need it for other things. Don't break my dollar protractors. I wonder if I have a protractor in my thing here.
Right? Anyway, an isosceles triangle has two congruent. Like that?
Okay, well, when you place your protractor, remember you put the circle on the bottom of the line at one of the angles. So I would just put it down here in the bottom left angle. And then you put the straight line going across here. And then you follow it up to the protractor, which should be looking similar to this. And you see at what angle this is hitting.
It's like a little, around 60.
Yeah.
It's around 60.
I think it's on 60.
It's under 60.
58.
Yeah, it was about 57 is what I assumed. But the book says it's 55 just because they can actually measure it. So I would have accepted 57 if this was your actual homework, but we're going to go with 55 since that's what the book says. So they're telling you this angle is 55 degrees. Well, if we know that angle is 55, is there another angle we know?
Yeah.
The other base angle. So we know that those two angles are 55 degrees, so it says to list all the angles, 55, 55. What's the third angle? How do I find that one?
Add the two numbers up and subtract it from 40.
From what?
180.
Very good. So add 55 and 55 and subtract it from 180.
10 minus 70.
Very good. So there is your three angles. When you classify this, we classified it as isosceles. Is there another name that we could classify this at, looking at the angles? Isosceles talks about the sides. What can we say about the angles? They are acute angles. So we would label this as an isosceles acute triangle. So whenever they tell you to classify this, think about how to classify the sides if you can, and how to classify the angles if you can. Most of the time you'll be able to say something about both. Every once in a great while you can't really say anything about one or the other. But. All right, any questions on that so far? Awesome, let's look at example 2. Try that again. All right, so we have a triangle on a coordinate plane. This means, can anybody guess what we're going to have to use to find the distance? Oh no, the distance formula. So first it says to classify triangle PQO by its sides, and then determine if the triangle is a right angle. So what we need to do is find the side lengths of each of these. So you're going to use the distance formula. Do you guys remember what the distance formula is? Distance equals, this is in your journals, but if you want to write it again, distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to do this formula 3 times. So I'm going to color each of these lines. We're going to say this, wow, that's terrible. This line is blue, this line is green, this line is red, and that's how we're going to find the distance of each of those. So for the blue line, we're going to say OQ equals the square root of, so x2 minus x1, so I'm just going to say 6 minus 0, and then that's squared plus y2 minus y1, so 3 minus 0, and square that. What's 6 minus 0? Is it, yeah, 6. And then, so we have 6 squared plus, what is 3 minus 0?
30.
Very good. So what is 6 squared? 36. What's 3 squared?
9.
So what's 36 plus 9?
47.
45. So square root of 45. So grab your calculator and write square root of 45. Or not write it, but type square root of 45 to get the actual approximation.
6.7.
So the answer is approximately 6.7. So we can say the length of this is 6.7. All right, now let's find PQ. We have the square root of x2 minus x1, so I'm going to say 6 minus a negative 1 means it's plus 1 squared plus 3 minus 2 squared. What's 6 plus 1?
7.
So I have 7 squared plus 3 minus 2.
1.
Good. So this is the square root of what's 7 squared?
49.
49 plus 1 is 50. What is the square root of 50? Approximately
7.1.
7.1. So we know this length is 7.1. Now we do the last one, OP. So I have -1 minus 0 squared plus 2 minus 0 squared. -1 minus 0 is
-1.
still -1 squared plus 2 minus 0,
Is 2.
2 squared. So if I square a -1, what do I get?
-1.
I get +1 because a negative times a negative still positive. So I have 1 plus, what's 2 times 2?
4.
4. So then I have the square root of 5, which is approximately 2.2. So we know this length is 2.2. All right, distance formula looks scary and long and crazy, but really not too bad. So what they're asking you to do now is to check for right angles. Okay, so the way we check for right angles is we find the slope, because remember, how do you find, well, a right angle would be a perpendicular line, right? It makes it 90 degrees. So how do you find whether two lines are perpendicular? Their slope is the opposite inverse, remember? So the sine is the opposite, and then you flip whatever the slope is. So let's just kind of guess if we had a right angle, which angle would it be on this? It's definitely not going to be this one over here, right? Q? That's not going to be a right angle. So it could be P and it could be O. Those two look similar. Which one? So let's find out the slopes of PO and the slope of OQ. That's what's going to help us determine right angles. So the slope of OP. OP, so I'm going to say, remember we find the slope by y2 over y1, the y2 minus y1 over x2 minus x1. So we're going to say 2 minus 0 over -1 minus 0. So the slope would be what? -2 over 1, which is just -2. Make sense?
Yeah.
So that's the slope of the little side. So the long side is OQ. So we're going to do 3 minus 0 over 6 minus 0. So that slope is 1/2. So let's look at these. We have -2 for one slope and 1/2 for the other. Are those opposite and inverse? Yes. If opposite inverse confuses you, then just multiply these two slopes. If you multiply these two slopes, what should our answer be? -1. So if I were to say -2 times 1/2, my answer is going to come out to be -1. That's the other way to test for it. If you can remember that it's opposite inverse, then you don't actually have to do the multiplication. But if that's confusing, then just multiply the two slopes. If you get a -1, then you know they are perpendicular. If we know it's perpendicular, I can put this little perpendicular sign right here. So this triangle is a right triangle. So right is talking about the angles. How else can I classify this? So I talked about the angles. How would you talk about the sides?
Right.
Look at the three sides. Do any of the measures equal each other? Nope. So what does that classify?
Oh, right.
Scaling. It's a right angle. We talked about the angles, but now we talk about the sides when we're classifying. Go look at your key concept. If none of the sides equal each other, then it's a scaling. So right scaling triangle. Okay? So we found out whether it was a right angle, and we also found the distance of each of the sides so that we could determine how to classify the triangle. I know it was a lot of work. Cool thing is, when you do this on your homework, I give you lots of points for this, because I know you did a lot of work. So this would be worth probably 12 points. So do it. Cool? Any questions on any of that? Again, just step by step. Follow the steps. It takes a few minutes, but you'll get through it just fine. Okay, we've talked about angles a little bit before, but I want to go over them one more time. When you're looking at a triangle and you extend the sides to form these rays that you see that they did here, then you see other angles that are formed. In the triangle, you have your interior angles right here. But then once you've extended the rays, you have your exterior angles. Now you notice they are on the angles that are vertical angles. See how they form an X? Okay? So you're going to need to use these. What they do is they form linear pairs with the interior angles. Sorry, the angles that form linear pairs with the interior angles are called exterior angles. That was hard to say. So your interior angle would technically be a linear pair across here. The exterior angle is the one that forms a pair that's next to. Does that make sense? I feel like I'm saying that really jumbled. Okay. So, Theorem 4.1 is what you learned yesterday in your activity, the triangle sum theorem. This is the theorem you can use to prove things. The sum of all the measures of interior angles always add up to 180 degrees. Am I just talking too much today? Or are they that early? Yeah, I got 4 more minutes. Okay, the other theorem you were supposed to write is Theorem 4.2. Whenever you extend your line of the triangle to get that exterior angle, you can see that the measure of the exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. So, all that being said, measure of angle 1 here is going to equal, let me use a different color, the measure of angle A and the measure of angle B. Here's the theory behind that, guys. You see how this is on a straight line here? If I were to finish this arc, angle 1 and angle C would add up to 180. You see that? Well, if I add up these two on this side, they have to be whatever's left over from 180 from that third triangle. So that's how they were able to use this as a proof. Does that make sense? So if you know these two angles, you can add them up and they'll tell you the measure of that outside angle. Real quick. Okay? I guess we will finish this later. All right, so we're going to do example 3 together. All right, so they've given you a diagram, and they want you to find the measure of angle JKM. Okay, which angle is JKM? It's this exterior angle, right?
Yeah.
Now, according to Theorem 4.2, what do we know about that exterior angle?
That equals the two interiors added.
It equals the two opposite interiors added up. So is there an equation I could write? I could say 70 plus x equals 2x minus 5. Right? Once you have that written, you can solve for x. So I'm going to move the x to the right and move the 5 to the left. So I get 75 equals x. Now, the question that is asking us is to find the measure of JKM. Have I done that yet? No, I need to do what? I need to plug in 75 where that x is. So I'm going to say 2 times 75 minus 5, which is 150 minus 5, so that's 145. So the measure of angle JKM equals 145 what? Degrees. Don't forget the little degrees because we are labeling the measure of the angle. All right, any questions on how we did that? Boys?
No, thanks.
No? Good? All right, I'll give you a second to finish writing it. So let's look at the next theorem. All right, when you hear a corollary to a theorem, this is a statement that can be proved easily by a theorem. So this corollary in particular is proven by the triangle sum theorem. So that's why it's called the corollary to the triangle sum theorem. It's kind of like saying theorem, the triangle sum was 4.1, right? So it's kind of like saying theorem 4.1b, like a little sub-theorem. So in this theorem, it tells you that the acute angles of a right triangle are complementary, which you already knew that. But see, if this is 90, then these two little acute angles have to add up to 90, which makes sense because all three have to add up to 180. So if you do 180 minus 90, then these two added up are also 90. So it's kind of common sense, but then you can use this to prove things. So let's look at example 4. So we have this picture of a staircase, and you see the pattern on the staircase. It's a tiled staircase that forms a right triangle. The measure of one acute angle in the triangle is twice the measure of the other. Find the measure of the acute angle. So when you hear that and they tell you it's a right angle, I automatically draw it on my paper and tell myself this is a right angle. Then the other thing they told us was the measure of one of the acute angles is twice the measure of the other. So does it matter which angle I write twice the measure? No, but I'm going to look at which one I think is fatter. So over here I can say that this one is 2x. And then over here this is x, because one angle is twice the measure of the other angle. Does everybody understand why I did that? These are little degree signs. It's hard to write with my little pen. So looking at this diagram now, can I find a way to solve for x? Yes, because we know the corollary says what about these two? They equal 90. So I can say 2x plus x equals 90, which makes the math very simple because you get 3x equals